This lesson is on the greatest integer function and piecewise functions. Now, greatest integer function is going to be a brand new function for you guys, I'm pretty sure. Piecewise functions you learned about in the 9th or 10th grade, or I guess it would be 8th or 9th grade when you took Algebra 1. And then we've talked about piecewise functions, evaluating them this year, but this is going to be graphing them. So anyway, functions whose graphs resemble stair steps are known as step functions. And the most famous step function is called the greatest integer function. And it's denoted by these double brackets. And it's defined as the greatest integer less than or equal to x. So in this case, x is what's inside the brackets. All right, so if we have a -1 inside those double brackets, that means the greatest integer less than or equal to -1. And if that number is an integer, it is just that number. All right, if that number inside a decimal or a fraction, we have some things to do. So if we have 2.1 inside, 2.1 on the number line would be about right here. So if we want the greatest integer less than or equal to 2.1, we go backwards to 2. All right, and then same thing for 3/4. 3/4 is about right here. If we want the greatest integer less than or equal to 3/4, we go backwards on the number line to 0. All right, and then when that number inside is a negative, it does make it a little less obvious, I guess. But -4.3 is going to be between -4 and -5. So we'll say about right here. If I want the greatest integer less than or equal to -4.3, we go backwards again to the next integer, which in this case is -5. So it always has to be smaller or equal to the number inside. Okay, so we're going to evaluate this function. So we'll put in -1.5 for x. All right, so inside those brackets, you should get 2.5. And the greatest integer less than or equal to 2.5 is 2. All right, for b, we'll put 1 in. All right, inside the brackets, we should get 5. And the greatest integer less than or equal to 5 is 5. All right. Now, I absolutely love fractions. Like, I like dealing with fractions better than decimals, but with greatest integer function, it's the one time that I like decimals better. So I know that -5/2, if I take -5 and divide that by 2, that's -2.5. And I'm going to add 4 to that. When I do, I get 1.5. And the greatest integer less than or equal to 1.5 is 1. All right, you guys try the second C on your own. We'll call it D. So use your little blue calculator or whatever you have or in your brain, to figure out what 7/4 is as a decimal, and then plug it in for x. All right, so we end up with 5.75 inside the brackets. The greatest integer less than or equal to 5.75 is 5. All right, I teach ACT prep this year, and we were working through a practice book, and this question was on here. It was not this whole question, just the D part of this question, but I thought it would be a good one to do with you all, just to show you how they might ask a greatest integer question on the ACT. So we have two taxi cab companies. Both have an initial fare of a whole number of dollars for one passenger. The fare increases a whole number of dollars at each whole number of miles traveled. The graph below shows the graphs show the one passenger fares in dollars for both cab companies for trips up to 6 miles. Both of these graphs are greatest integer functions. So we're going to find the following. So A asks us to find f of 4. So I labeled ABC cabs F and Terry cabs G. So if I want to find f of 4, I go to the f function. X is 4 here. So I'm going to go up. Now, if there's a hole in the graph, that is not the value of the function at that point. So we have to go all the way to the solid circle or the solid line, and that's going to be 10 or $10. All right, for G of 3, I'm going to use the G function. So 3 is here, 3 miles is here. We're going to go up. We don't use the hole, we use the solid. And that is going to be 7. Right? And then f of 2.5. So 2.5 is between 2 and 3. We'll go up. We hit the solid line at 6. All right, and then for D, when the fares of the cab companies are compared, the fares is compared, what is the cheaper fare for a 5-mile trip? Okay, so 5 miles for ABC, go all the way to that one. That's going to be 12. 5 miles for Terry, we go to this one. That's going to be 9. So $9 is the cheaper fare. And that's the actual one that was on the ACT. All right, and then for E, we're going to use the greatest integer function to create a model for each of these. All right, so let's start with F. Now what we need is the slope and the y-intercept of it to find this. Now, I know it's been a while since you thought about that, but the y-intercept on the f function is going to be 2. So where it touches the y-axis, even though there's a hole there, it's fine. That's going to be 2. And then the slope is going to be the rise over the run. So from this point to this point, you go up 2, right 1, up 2, right 1. That's the slope. So what I would do is I would put the slope x inside the brackets and then plus the y-intercept on the outside. Now there's multiple ways we could do that. The slope could go in front of the brackets. The whole thing could go in the brackets. But this is one way that I'm sure that it is right. All right, for G. You guys look at it, found the slope, find the y-intercept, see if you can do that one on your own. So it looks like the y-intercept is 4. On the slope, we go up 1, right 1, up 1, right 1, up 1. So a slope of 1 means just x. Okay, let's look at example 3. A parking lot charges $10 for parking up to but not including 1 hour, and $4 for each additional or portion of an hour. Use a greatest integer function to create a model for the cost P of parking in the lot for X hours. Okay, so I want you guys to look at 10 and look at 4 and decide which one of those is the slope and which one of those is the y-intercept. So how much it goes up for each additional hour is definitely going to be the slope. And this is going to be the y-intercept. All right, and we're just putting this kind of into mx plus b because it's a greatest integer function. We've got a little double bracket. All right, so we have got 4x inside plus 10. All right, and then the last part of this, we are going to graph a piecewise function. So again, I don't think you guys have graphed these since Algebra 1, and the ones we're doing, obviously, are going to be more complicated than what you did in Algebra 1, so I might teach it a different way. You may not even remember doing it, I don't know. But I know if you do it this way, that it's going to work for all the weird ones we might have to do. So when we're graphing a piecewise function, the first thing that I want you guys to do is make a table of values for each piece. So this one has 2 pieces. So I'm going to do a table of values for the piece that is y equals negative 1/2 x plus 2. And then I want you guys to make a piece for y equals, or make a table for y equals the quantity x plus 2 quantity squared. All right, then what I want you guys to do is put the number or numbers from the inequality in the table and circle it. Okay, so the inequality is this part right here. So whatever those numbers are, if it is in your piece, doesn't matter if it has the or equal to bar, if it is written for the piece for 1/2 negative 1/2 x plus 2, you put it in the table. And then we are going to circle it. It is a special point. It's going to be the end point on a graph. So it's going to be a starting or stopping point on your graph. All right, next, we're going to determine if that end point needs to be an open or a closed circle. And what determines that is the inequality. So for this first piece, the inequality has an or equal to. That means this one's closed. For the second piece, it doesn't. That means this point is going to be an open point. All right. And then we are going to fill in the table of values as described by the inequality for that piece. So for the first piece, the x's need to be less than or equal to -2. Now this is kind of a more difficult piece because we have that 1/2. So we could put -3, -4, but because it's a fraction, I am going to put -4, -6. I don't want to deal with decimals. That doesn't come up every time, so don't let that stress you out. All right, for our second piece, we want x's that are greater than -2. So greater than -2 is going to be -1, 0. All right, so then I'm just going to take and fill in my table. So everything from this first table, I'm going to multiply by -1/2 and add 2 to it. Everything in the second table, I'm going to add 2 to it and then square it. Now hopefully in your minds you know that one side of this is going to be a line because y equals -1/2 x plus 2 is a line. And then the other side is going to be part of a parabola. I guess I should say the first side was part of a line. The second side is part of a parabola. So when you get done, make sure that matches up. Okay, so For this first table, I'm going to graph these points. My end point is going to be a closed circle. All right. Then I'm going to start at the end point and then connect my points to the left. All right. There is one piece of my graph. All right. For the second piece, I know my endpoint is at -2, 0, and it is an open circle. The rest of my points are just regular old points. Right. And I start at the end point and go through these points. Now, I know this isn't straight because it's a partial parabola, so it's going to look something like that. That's how you graph a piecewise function. All right, so I'm going to go to your worksheet real quick. Pause the video if you need to grab your worksheet. I want to talk about the table for number 15. Because this piecewise function has 3 pieces, you're going to have 3 tables. Okay. And then remember, if I look at the first piece, I have a -1 in my inequality, so -1 goes here, and I circle it. If I look at the second piece, I have 2 numbers, -1 and 1. They both are going in my table, and they both are getting circled. One at the top and one at the bottom. All right, and then for my final piece, 1 is in my inequality, so it goes in my table and it gets circled. All right, and then for the first table, I want to pick x's less than -1. Now there's no fractions on this one, so I can just go -2, -3. For the middle piece, I'm needing x's that are between -1 and 1, and so that only integer that is between -1 and 1 is 0. And then for the last piece, x's that are greater than 1. Okay, so hopefully that'll help you on that one. And you just plug in those values by hand and graph each little section.